All right. Let's see. So no mic, no mic, no headset mic. We'll see how the audio is, anyways. If anyone cares. Minimum distance to target element easy. Given an integer array nums, 0 index, when 2 integers target and start, find index I such that nums at I equals target, an absolute at I minus start is minimized. Find 2 integers target and start. Given 2 integers target and start, find an index such that nums at I equals target. So the target is the value that you're looking in the array, and the absolute, okay, and it's the closest to the index. So start is the index within the array that you want to kind of locate at, ideally, and you want to find the first value that is close to that position, that start position, and then return how far away it is. Okay, sure. So target value is 5. Looking at starting position is 3, so this position right there, 5, the closest 5 from this position is 1 away. And then here, target is 1, starting is 0, you're already there. And it's guaranteed to be there, so you don't have to return -1. Okay, sure. So this should be O of n for sure. I guess what you probably just do is have some sort of loop. You probably want to do a loop starting at the index. Trying to think if I can somehow. So if you're going for a middle index and you're in a long array, you kind of want to prevent yourself from going out of bounds. So, okay, so let me go ahead and say closest end is the smaller of going to the front and going to the back of the array from start. So I guess that'd be start and n minus start, something like that. N is the length of the nums array. And so I can guarantee that I have enough to iterate over in that case, if I go from 0 to closest n difference from start. So for k in range, or say delta in range, closest end, if nums at delta, nums at start plus delta equals the target, or nums at start minus delta equals the target, return the delta. At that point, I think it might be that you have to go through the remaining values that are on the longer side away from the start. So like if the start is like index 90 out of 100 in the array, you have 10 on the right side and 90 on the left side, so you do 10 and 10 on both sides, and then you still have to do like an 80 on the left side to get to the 90 on the left side. So So what is the logic there? It's like I have to see which side is longer, further away, has more elements, farther away from the start. So I think if it's closer towards, I guess if start is bigger than half of target, half of the end, the start is on the something like this. Then there should be more elements on the front end that I need to go through. So it'd be something like for delta in range. Actually, I think maybe I can do for the index in range. Start minus the closest end, the distance to the closest end, decrementing down to 0. I want to keep this as the delta, actually. So why don't I just try to return it, right? Oh, whatever. If nums at k is equal to target, return start minus k. Else for k in range, let's say start plus closest end to n. If nums at k equals target, return start or k minus start. I think I might need to, I think this might still be wrong with edge cases, maybe some edge rounding cases, but I'll try it out. And it should never return -1 since it should return something, but okay. It doesn't inspire me confidence to pass basically one non-trivial edge case. Non-trivial test case, I mean, sorry. Let's say the target is say 6, 7, 8, 9, 10. Say the target is 2, starting at 8. Okay, I think I need to try something closer. Okay, let's actually try starting 8, target 8, starting at 2. I probably also need to test like if it's right next to the middle. Well, if it's next to the middle, then it's not that hard actually. So maybe where might this screw up? Like maybe target 1, starting position 6 or 5 maybe. This hopefully works. Okay, all right, I'm done with test cases. That's the end. God damn it. Consarn it. Starting at 9. Interesting. Start 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So starting here and ending here. So I think it should be doing this case, right? Start is greater than halfway. Oh my god. It's supposed to be n divided by 2. That's pretty bad. Alright, we should probably actually use a test case that failed. Oh my god. Consarn it. Alright, targets here. Start is at 3, 0, 1, 2, 3. Okay, so this is the case that I was maybe worried about, the rounding error, kind of. Because there's actually, the star is actually closer towards the front than the back. So there's actually 3 in the front, 4 in the back. So it's doing the wrong thing here. I think maybe I should be doing start times 2 is less than n or something like that. So that it doesn't have the rounding quite issue. So start is 3. I think this probably works. No, that's wrong. That's wrong. There should be start times 2 is greater than or equal to n. Something like that. I have just the opposite logic there. Fudge. Fudge. So it's 0, 1, 2, 3. The length is 7. No, the length is 8. Oh, closest end should be +1, I think. Yeah, it should be closest end is +1 here. Because it should never be 0, I don't think. Does this go out of bounds somehow? Alright, let's maybe see. Yeah, it goes out of bounds. Closest end start is 3. So 0, 1, 2, 3. 0, 1, 2, 3. So that's technically that's 4, right? The end is 4 away. Okay, maybe I need to do something like this. If nums at target or nums at start equals target return 0. Okay, I think maybe I just need to remove that kind of edged type case. So closest n is just strictly the non-zero difference from the starting position to the other positions. Zero, 1, 2, 3. So start minus 1, start minus 2, start minus 3. Get the feeling it should be +1 here. but then that's the same as what I had before. I think it should be like something like this. N minus start. So here it's n is 0, 1, 2, 3, 4, 5, 6, 7. I think this might be n minus start minus 1. Okay. I think maybe this works. Okay. I think maybe I didn't need to actually factor this out. I could have gone 0 to closest n plus 1. Yeah. Just gonna change that code just a little bit. And this thing, yeah, this is fine. I think that's still identical. All right. Yeah. So many ways to do this. Above approach is to iterate, is to find the closest end point of the array, either the front or back. Find the distance to that closest closest end. Iterate over the indices that are start plus delta, where delta can go up to that closest end value, since it won't go out of bounds. Return immediately if the value at that position is equal to the target value. This is basically a short circuit return kind of. And then lastly, have logic that iterates over the indices that are on the kind of longer side. For example, let's say the start is at 90, the length of the array is 100, longer side is in front. The closest end value is 10, so you need to iterate over kind of the 90 minus 10 equals 80 to 0, since that wasn't captured in the previous loop. Have similar logic for both sides, kind of. So this is the logic for if the longer kind of side is towards the front. Longer being there are positions that are further away from start in that side, and this is if longer side is towards the end of the array. All right, time complexity. This is definitely O of n. since there needs to be at least, or at most, one pass through every index in the array, doing constant work. In the worst case, you have to go to the very end of the array to determine that, to find the value. Basically, this of one, since no extra space is needed